What's up? This is Matt Brown with another IoT hacking video. This is going to be the next video in our series on the Netgear NightHawk router. In this video, we're going to start taking a look at network traffic and analyzing the network traffic that is coming out of this router, out to the internet, and we're going to talk about a general approach to capturing all that traffic and analyzing it, and specifically how to decrypt SSL or TLS traffic when the traffic is encrypted. You can't see inside that encrypted channel. We want to see the raw HTTP requests that are being sent out to the cloud. We're going to discuss how, with that root shell that we got earlier, how we're going to be able to get in the middle of those SSL communications. So with that, I'm first going to dive into my general approach. This is actually an approach that I've evolved over time. I used to have a Raspberry Pi that implemented this. Now I'm moving to implementing this on my computer, where everything else, all my other tools live. And so I have made this into a GitHub repository and scripted this whole process out. So this is a repository I just threw up called man-in-the-middle router, and I created this extremely graphically intense diagram to just to kind of wave my hands at and explain my thought process here. So when I'm analyzing an IoT device, I want to be able to see all the traffic. That's where I start. I just want to see the traffic. I don't care if it's encrypted. I'll just watch where that encrypted traffic is going to. I'll see if there's any unencrypted traffic. I will see what DNS requests are being made, see if NTP is in use, just all understand what protocols, what is going on. Does the device only communicate on the local network? Does it communicate out to cloud servers? Things like that. So this setup will allow us to do that and more. So the way that I gather all of that data is that on my Linux computer, which we're going to demonstrate here in a minute, I am running a number of pieces of software and kind of piecing them together to turn my machine and a couple of network interfaces, a minimum of 2 network interfaces, into a router that I will then connect the IoT device, the device under test 2, on this side of our diagram. And then that will allow us to view all the traffic as it flows through that router out to the internet. And we can also optionally intercept traffic. So we're going to go through this at a basic level, and then we'll talk about that interception, the kind of man-in-the-middle attacks we can do after that. So you can see this setup right here. This is all software running on my computer, and I have 3 interfaces. I said you only need 2, but I do have it set up with 3. So over here is the LAN side of my router, the local internet side. And then over here, obviously, is the WAN side. So in this diagram, the WAN side, the wide area network, the internet side of the network, is just going to be whatever interface on my computer has internet access under normal circumstances. So we're not really going to do a lot of configuring this interface, but we do need to know what interface that is to feed into the script so that this routing will take place properly. But a lot more is going on the LAN side, and you can see it's not actually labeled LAN, it's labeled BR0 because this is a bridge interface. In Linux, a bridge interface is a kind of virtual interface. Somebody can correct me because that's probably not correct, but it is a quasi-virtual interface that one-to-many interfaces can connect to. You can glue multiple interfaces together and they'll act as one. And so that is what we're doing here, is we're creating a bridge interface and we're adding a Ethernet interface. In my case, I have a USB to Ethernet adapter that sits over here on my desk that is connected up to my desktop that I'm looking at here, and that allows me to to have it just conveniently over on the desk, that interface. I also have built into my desktop machine a wireless card. And so that also allows for Wi-Fi based IoT devices where I can also add them to that same LAN network. And that is all connected to this bridge interface. On that bridge interface, I am running DNS mask, and that's the DHCP server. So that will give out IP addresses within a certain range to the IoT devices, just like your router would, right? We are acting like a router here, so we are going to give out IP addresses, which is what these IoT devices are going to expect. They're all going to DHCP, get an IP. Generally speaking, you don't statically assign IP addresses to your IoT devices. That's just not how they work. And then gluing these two interfaces together, because if you just did that, the devices on the LAN would never be able to get their traffic out to the world. And so we have a set of IP tables rules that creates a NAT. And so NAT is Network Address Translation. Had to remember that on the spot. And so what that's going to do is it's going to translate the local IPs on the LAN side to whatever the quote-unquote public IPs are on the WAN side. Now, in our lab environment here, that's also going to be a private IP, right? Because I have my own, network router on the other side of this. But IP tables is going to do that natting. And then optionally what we can do, so at this point, what we can do, it should be noted, is that on this bridge interface, we can run Wireshark and we can see every single packet that this device wants to send out over the WAN to the internet. We can sniff, we can sniff on either interface, but I generally sniff on the bridge interface, and that will give us visibility into all the traffic that is going across these interfaces here. Then what we can do is with a slight modification to the IP tables rules, we can select some traffic to not forward out to the internet, not to forward out over here to this WAN interface, but we can redirect it locally to man-in-the-middle proxy, which is an SSL proxying and analysis tool that is effectively going to act as if it was that server out in the internet and make and receive an SSL connection, a TLS connection, and then it's going to, if it's successful, it's going to proxy all that data out to the real server over the WAN interface to wherever it's supposed to go. And that way we can sit in the middle in an encrypted session that the IoT device has with the cloud. Now, for our problem, which we will discuss today, that would work. We would be able to run this man-in-the-middle proxy tool, and we would be able to see all the traffic if the IoT device is not properly doing certificate validation and checking that the root CA that is signing the server certificate for whatever cloud resource that it's making a connection out to. If it's not validating that it's from that it's signed by one of its trusted root CAs, like a publicly trusted root CA, then we would be able to intercept that traffic if it's not doing that validation. But if it is doing that validation, it will fail, and we will need to take the next step, which we will demonstrate in this video, of doing some tinkering on the device to make it trust our proxy's certificate here. You may be used to this if you have run, if you've done kind of some classic web hacking with Burp Suite or OWASP Zap, a web proxy that you proxy your traffic from your web browser into. You usually have to go into your web browser and put that proxy certificate into your web browser. Well, how do we do that on an IoT device? Well, that's going to be a more case-by-case basis for how we do that, but we're going to demonstrate that on our Netgear router today. So with that, I'm going to jump over and we're jump past Wireshark for a second here, and I'm gonna go back to that UART shell that we have here, and just observe something that I saw scrolling by during the initial boot up process, a little bit after the boot process, because this is after it gets an IP address and all that fun stuff. I saw this message in the UART console output. And so it is saying that it is running, where's the beginning of this command? It's running wget. Where are we? Here's the beginning of it, right here. It's running wget, whole bunch of options. There's some really important options. So the first really important option is CA certificate, and then it shows me where the CA certificate file is. And we're going to find out that this file actually has a ton of publicly trusted CA certificates, CA root certificates, that it uses as its base of trust to decide whether it should trust a server certificate that is signed, hopefully by one of these root certificates. And then the other one is where it is making this request to. Here we see it is, deceptively, it's HTTPS, so it is making a TLS and SSL connection, but then it's like, it's called http.firmware, but that's not the protocol. That's part of the subdomain here. So if I want to get in the middle of these communications and see what's actually taking place when this request or any other request that is being made to this site occurs, we are going to have to add our certificate into this file that we see right here. So we're going to try to do that, and we're going to notice a little bit of a roadblock. So the first thing I did was I'm like, okay, let me look at this file. Let's look at it. Okay, there's like a bunch of bytes in there. Yeah, this is probably what I want. I'm going to use VI to edit the file. And then I tried to add my certificate into here. And oh, you can already see the error here. So it's read only. I am the root user. So the reason why I'm getting read only, we kind of discussed this in some previous videos when we did the firmware extraction, is that the root file system on this device, we can see right here, is mounted as read only. And moreover, it is a squashfs file system. So we can't do like the mount -o remount trick to remount this as read write with the write permission enabled. The squashfs file system by design is a read-only file system. You can never write to it actively through, like mounting the file system in Linux. That is not a part of that file system. You would have to rebuild the file system and then flash it to the raw flash chip is how you would have to perform that update. So we're going to have to get that file to be writable in another way. And so the way we're going to do that is we are going to find a place where we can write to. So all of these places down here are great targets. We can see a block file system is being mounted onto a directory. So I'm going to pick /mount. And I'm going to also, I need to copy this path. And so what I'm going to do first is I'm just going to copy that file that has all those certificates in it, the one that we want really to edit, and I'm going to copy it over to this other directory. So now I have a copy of it right here. And then I'm going to add to this file my CA certificate. So if you've never used man-in-the-middle proxy, the first time you run man-in-the-middle proxy, it's going to create a folder in your home directory called .mitmproxy. And then there's going to be all these different versions of the CA certificate, and and then you also have the private key that gets generated in here. But we're going to go mitmproxy CA cert.pem. We want the PEM format. So I'm going to copy this, and then we're going to come over here, and we're going to edit the version that is editable. So we're going to go to the end of the file. I'm going to paste it. This is in a UART shell, so it acts a little weird, but our certificate is there. I'll just let it spit out all the certificates, and we will see ours at the very end. Yeah, this is going to take a while, isn't it? All right. Come on, man. All right. So now we're going to talk about what we're going to do next. Is now we're going to have to, there it is. We're done. Okay, cool. We can see that our certificate is actually there at the end. Cool. But this doesn't help us right now because that wget command is not checking this directory for its CA certificates. So what we can do is we can run the following command. We can run mount with the bind argument. And you can actually, in Linux, you can do this. You can mount a file over top of another file. And so this is how we can kind of edit a read-only file in a read-only file system. We can't really edit the file itself, but we can mount a different file that we have already changed over top of it temporarily. Now, obviously, when we reboot, it's not going to, this is not going to happen, which is going to lead to a bit of a problem for us. Okay, I'm just going to copy from my other screen all these arguments. So here we can see we're mounting our file that we have in the mount directory over top of the one in opt-ext agent certs, that mega bundle. Okay, so we run that command, and now we can see that these are effectively the same file, and we can do that by doing this. This is one way you can see. We can see that the sizes of these should show up as the same. And if you run mount, it's kind of weird because it doesn't show exactly what file inside of dev mtd block 18 is being mounted to here. But we do see this additional entry when we run the mount command that's being reported as a mount. So that's all good and great. Now we're going to have to get our man-in-the-middle router set up, but we're going to come back to another problem that we're going to have because this web request that we are trying to capture only happens during the initial boot up process. And so we just said that this mount command is not going to persist across a reboot, so we're going to have a bit of a hack to easily make sure we're not trying to race to type in our mount command in time. So we're going to first go over here where I have the router software running, and I'm going to turn that off really quick, and we are going to open this script. So you can see that this is effectively the same script that we have here. I made this a little bit more generic for you at home, right? I gave these interfaces maybe the more common names that in a Debian-based operating system they would appear. I'm running Arch Linux, so your mileage may vary. You're definitely going to have to edit these parameters for the interface names, most likely. But we can walk through the rest of the script really quickly. I'm going to do a whole video on an in-depth man-in-the-middle setup. So that's not what this video is. But we can scroll down. There's a bunch of variables that we set up. We set up some config files. I run a bunch of ifconfig commands to basically rip down all those interfaces and reset them. And so I start from a clean slate. Here we're creating on-the-fly config files for DNS mask. That's our DHCP server. And host APD, that's the Wi-Fi part. We're not using that in this case because this is an Ethernet device, but if we're pen testing a Wi-Fi based IoT device, we would use this host APD config file to configure a wireless network. And then we set up the bridge interface here. So we bring up all our interfaces, and then we use this bridge control command to create that bridge interface, that BR0 interface, and then we add the LAN interface to it. The Wi-Fi interface will automatically get added. Host APD will do that for you. You don't need to add that in. And then we have our IP tables rules. So I want to focus on these because this is what we'll edit. We'll tweak this a little bit. So all of these rules, don't worry about it. All that they do is they set up that NAT. They set up that bidirectional path that links the LAN to the WAN in our router. This bottom rule is what we are going to want to uncomment and work with. So I'm gonna actually move over, and then at the end here you can see we're just we are setting up a static IP on the LAN, and we're running DNS mask and host APD. That's what the script does. So now I'm gonna go and talk about how we're gonna edit our script down here at the bottom. So we want to uncomment this. And so we are going to be routing some of that traffic. You remember that diagram where some of the traffic is being routed down to man-in-the-middle proxy. That's what we're doing with this rule right here in IP tables. So it's on the bridge interface, don't have to change that. TCP, that's the protocol we're using. If you were trying to man-in-the-middle NTP, which is fun to man-in-the-middle, you can do some interesting things with that. You would obviously change this to UDP, but we're working with TCP today. And then the destination. So that's what I want to figure out what the destination IP is going to be. Because I don't want to, at this point, try to man in the middle all of the traffic. And so let's go back. Oh, I catted through all of that stuff, didn't I? Okay. Let's see how much scroll back we have here. Okay, this is the time when it's not as cool to not have the scroll bar on your terminal. It looks cool, but all right, here we go. Where is that command we're looking for? All right, here we go. Here's our command, and here is the server. Okay, so over here, our IP tables rule. We want to figure out what IP this is going to resolve to, so we're going to run ns lookup, and we can see, oh yeah, this is one of these weird things. Somebody that understands DNS more than me is going to know a way better way to do this, but there's actually a couple IPs that this resolves to. Yeah, of course, now it's always resolving to that one. When I did this last time, there was potentially like one other IP that this is going to resolve to. All right, tell me in the comments how to figure that out. I don't know if I can. All right, destination port. Yeah, destination port 443. I mean, there wasn't a port specified in that wget in the URL. There wasn't a port specified, so HTTPS is port 443, and we're redirecting to port 8081. I always run man-in-the-middle proxy on 8081 just because I usually have like Burp Suite running in another window on 8080, so I don't have conflict if I run it on that port. So, whoops. All right, so let's save and edit that, and then we're gonna just run this. And so this bash script, really simply, it takes an argument up or down. The down command will just tear down the router and put your network settings back as if you had never run the script, and up will take things down and then set them back up again. So if you change your config file, if you change any of the configs, you can just run up again and it will tear things down and build them back up. Seriously. That IP is not going to change, but it's going to change when we reboot the router. Just watch this. All right. So there we go. Even the Wi-Fi SSID is up, but we don't care about that part. Yeah. So the Wi-Fi part will stay running in the foreground, but again, we really don't care about that today. So over here we have, you can see my history of all the man-in-the-middle proxy I'm running. So I'm going to get that ready, and we have the router set up. This is all good, but now what we need to do is we need to get ready. So I have copied over here this command, right? We're going to run this command, but we want to run this. We want to boot the device, and then we want to have this command run before that wget command happens. But there's some assumptions we can make here, and it turns out they are true. And that is, that command does not run unless it detects that there is internet. So what we're going to do is we're going to simply unplug the router, and then we're going to reboot it. And that way, we can, at our own leisure, wait for everything to go down, come back up, and we'll be able to mount the thing. And then once we know the certificate file is mounted with the file that we've modified that has our man-in-the-middle proxy certificate in there, then we can plug it in and observe the traffic. Okay, so what I'm going to do here is, this is always annoying because it's going to say that, oh, the interface does exist. Nice. Sometimes Wireshark will give you problems when my script, because it tears down the BR0 interface and it like brings it back up all the time. So sometimes it won't see it in the list, but saw it that time. Actually, I'm really skeptical that that actually worked correctly, so I'm going to relaunch it because we got some time. Whoops. All right, bridge 0. We're listening to that traffic. Oh, yeah, you see where it hits like hit enter to continue or whatever? If you hit that too fast, it'll drop you into an emergency shell on this router. I believe that that is because this is based on DDWRT or OpenWRT, and those router operating systems have a thing called fallback. No, not fallback mode. It's failsafe mode. And in that failsafe mode, if you hit enter like fast enough in the boot process, sometimes it's like sometimes you hit F. Maybe this is a little bit different, but it drops you into an emergency shell. And in most cases, you can use that to root the device. So if this device had a login prompt, we could have used that emergency shell to mount whatever system is going to be hosting the shadow file, and we could enter in our password. Okay, so so now I think I'm safe to start like hitting enter. Yeah, so I still don't have a shell yet. You'll notice that, but aha, I have a shell, and I'm going to paste that command. Did it paste? Nope, it's not pasting. Let's copy it again. There we go. And now we can run the mount command and verify. Okay, we're good. And now we are going to sit over here and observe what happens when we plug in our interface. We get DHCP, ARP, bunch of other stuff. Let's just look at TLS and DNS just to get rid of a bunch of noise. Ooh, okay, so here it is. This request we should have intercepted in theory if we did everything correctly. Aha! So there we did it. We convinced this system to trust man-in-the-middle proxies CA certificate, and we're seeing all these requests here and their contents. So here's the request, here's the response, and so this is a really key thing when you are pen testing or doing bug bounty hunting on an IoT device like this. Sometimes your attack is still going to be against a cloud server at the end of the day. The scope target could be a cloud server that is associated with the IoT device. But a lot of times, that could be very black box, and you don't have a lot of information because that server is only meant to interact with a device. It's not really, there's not like a graphical user interface, like a bunch of HTML that's sitting on this site here. But if you can gain insight into what the URL parameters, what the different paths on the server are from intercepting the TLS or SSL communications on a device like we just have, you can have a lot better insight into how to attack the server, right? So with this URL, I already kind of tried this. It didn't yield anything yet, but okay, we see there's a path that starts with what is clearly the model number. There's like 2 model numbers on these things, but this is like one of the model numbers, the R6700V3. And so maybe I could try to change that to another known device model number and version and get back some different data out of this server. That could be something I could try. And so we can look at this other stuff. I don't think there's anything super sensitive yet from what I've seen in these specific requests. But obviously, research could show otherwise. And so this is often the first step that I want to take when I'm digging into traffic that these devices are communicating back to their cloud servers. There's a lot of other traffic that's going on this device, but in this video we just wanted to focus on a small subset of the example. And so thank you for watching this video. Yeah, I just want to remind you that I will place this repository in the description. If you have any questions, please post down in the comments. And coming soon, there's going to be another place where you can reach out and interact more directly with me and hopefully form a community of fellow IoT hackers. If you have watched the video up until this point and haven't clicked off of it yet, I am going to be making a Discord server that I'll probably release later this week, and it will be a place for, you know, fellow hardware hackers, IoT hackers, people who are just interested in this stuff to discuss, ask questions, talk about projects, talk about future content that you want me to do. And so I just want to thank everyone who has been watching these videos, who has been subscribing and commenting. So I just want to build a place where we can all work together on our various projects and getting better at this stuff. So that's all I got for you. Have an awesome day.